Alright, section 9.3 is experimental probability. It is actually doing something. We've talked about theoretical, what maybe it should be, but this is actually doing it. As it says here, the number of times an event occurred by the actual total number of trials. Examples here of flipping a coin, rolling a dice, how many times does one come up? How many times does heads come up on the flipping of the coin? It is actually doing it and seeing what you actually get when you do the trial of whatever you're trying. You're asked here, 13 out of 20 emails in your inbox are junk. What's the experimental that your next email is going to be junk? Well, it's the number of times the event has occurred. Well, it's occurred 13 times. Hold on here. Change colors here. 13 out of 20 it has happened. If I go ahead and divide 13 divided by 20, I get a 0.65. Put that into percentage, multiply it by 100, is 65% of the time I have gotten junk email. Well, up here, the using the experimental probability, my next email probably is going to be, sorry, bell here. There's a 65% probability that my next email is going to be junk. All right, it rains 2 out of the last 12 days in March. If that trend continues, what would you expect to happen in April? Well, 2 out of 12, which, by the way, if you want to reduce it, is 1/6. 1/6 the time in the last 12 days it has rained. Well, if you look here on the calendar for April, there are 30 days in April. So if I go by the premise of 1/6 of the time it's going to rain, and I have 30 days in the month of April, I'm going to go ahead and cross multiply to solve that. I'm going to get 6x equals 30. So theoretically, looking at the experimental probability of March there, it's going to rain, 5 times in the month of April. Alright, we have a bar graph here. It shows us the results of rolling a number cube 50 times. What's the experimental probability of rolling an odd number? Well, here's our odd numbers, 1, 3, and 5. Down here I'm looking at experimental probability. I want to know the probability of an event, the number of times the event occurred, divided by the total number of trials. Well, let's look at this. The 1 happened 10 times, 3 happened 8 times, and 5 happened 8 times. So 8 and 8 is 16, and I'm going to add 10. It happened 26 times we rolled an odd number. As it already has said, we rolled it 50 times, so I'm going to divide 26 divided by 50, and I'm going to get 0.52, which is 52% of the time I got an odd number when I rolled my dice. Let's compare that to the theoretical probability. Theoretical, as it says, we should now know number of favorable outcomes divided by the possible outcomes. Well, there's a total of 6 possible outcomes, and odd happens 3 out of 6. We, of course, know that is 1/2 when we reduce that. So 1/2 is 50%. So the second question says, how does this compare with a theoretical probability of rolling an odd number? Well, 52% to 50% is pretty darn close, so we definitely have a fairly close number in terms of probability of odd numbers when we actually experimented and did it. Hope you followed along. We will talk more about probability and play some more games as we move on this week. Thank you for watching, and have a good night.